Once again, welcome to the video lessons of physics class 12th. Today we will be covering the topic the potential due to group of charges and electric dipole. The content we will take up will be the electrostatic potential due to number of charges, means the group of charges, and secondly the electric dipole and potential due to it at any point, and at a point on axial line and also at a point on equatorial line of the electric dipole. So these will be the points to be covered. Now let us start with, earlier we learned about the potential at a point due to single point charge. Now let us see what happens if there is a number of charges, source charges available, like Q1, Q2, Q3 and up to so on, say Qn. So let us consider these source charges, and at point P, which is distant R1, R2 and so on away from these source charges, we have to find out the potential. So we can find the potential with the following concept. I told you that the potential is the scalar one. Which type of quantity? This is the scalar one. So there will be at point P the potential due to each charge, each source charge, right? And these source charges may be having the positive or the negative sign as well. So what will be there? Then to find the potential at P, we can take the algebraic sum. Which sum? Not the vector sum, which sum? Algebraic sum for the potential at P due to individual charges, right? Simply we can say that Q is to appear here with the sign of the charge. If positive, then positive. If it is negative, then let us put here negative sign. So we can sum up and can get this result. Similarly, we can proceed for the n charges available. Now let us proceed to find the electric potential at any point due to electric dipole. This is the electric dipole. We are familiar with the electric dipole, the two equal and opposite charges kept apart by the very small distance, that is length of the dipole to be very small. Okay, this is the electric dipole. System of the two equal and opposite charges separated by a very small distance. First of all, let us have the point P where this electrostatic potential is to be determined. Let this P be distant R from the midpoint of the dipole, and R1 and R2 respectively is the distance of A and B, or minus Q and plus Q charge from the capital P point where potential is to be determined. So same principle to be used, that is the result is going to be how much? V is equal to V1 and V1 plus V2. V1 is potential at P due to minus Q charge, so here it is. And then V2 is the potential at P due to plus Q charge. So plus Q, distance of plus Q charge from P is PB. Let us sum it up. Let us calculate the values of PA and PB to calculate the potential at P. Dipole length very small. So we can have this distance PA as almost equal to how much? PM. We have extended this PO and we have drawn normal from A on this line, and also the normal BN from B on this line, that is the extended PO. So PA almost is equal to PM. So geometry from the figure we can see very simple that PA is equal to PO plus OM. So we will have R plus A cos theta, and PB also we will have R minus A cos theta. So the potential, by putting the values, these values here and solving, taking LCM, we will have this, right? We are familiar with Q into 2A, that is the product of Q into separation of the two charges, as P. What is P? Electric dipole, moment of the dipole, electric dipole. We will have this, right? Told you P is equal to Q into 2A. So this is the general expression for the potential at point P, or point P if lies on the axial line of the dipole. So we see what will happen. Theta will be equal to 0 if P point is on this line, right? Theta will become 0. So we will have this expression. Further, if we use the concept of the dipole that A is much more smaller than R, right? So A square will further be less than the R square. So we can omit this to have this formula, right? And for point P on equatorial line means, here it is, dipole को क्या करे, divide कर दे two equal parts में, right? Theta will be how much? 90 degree. And what about the cos 90? Cos 90 is 0, right? So V will become equal to 0. So on this equatorial line, each point will have the same potential, and that same potential how much equal to 0, right?